like force and electromotive force uh, in a circuit where the circuit has a resistance R and a battery with a small resistance R as well, and current I. So the electromotive force basically can be approximated to the terminal or functional voltage, and also to the voltage across the battery, and then the voltage across the resistance. Yes, so the form it will take is IR plus I capital R, if you know what I mean. So I into R plus R. See, as V is equal to IR, and I is equal to V by R. Uh, so I, as we have this terminal or functional voltage equal to electromotive force, so I would be equal to E by R, but R is the resistance in general. In this situation we have R plus R, small r plus capital R, the total resistance of the loop. Okay, so just to have this stand out, A, and electromotive force by definition can be equated to work by charge. Yes, we will see whatever fits in the situation. uh, for example, we have these assertions, um, here as A, here this is B, and this one can be C. So if epsilon is equal to W by Q from A, and epsilon is equal to I into R plus R, here C, yes, R plus R. So we can equate these two. Work by charge is equal to current into small plus big resistance. What we get is work in the EMF situation, electromotive force, charge times current, small plus big resistance. This is an extension, not a basic version of the equation. For the basic version, we should stop here, let's say. Okay. From A and B, we can say that Vt is equal to since epsilon Vt is equal to epsilon, and epsilon is equal to E is equal to Vt is equal to E is equal to W by Q. So Vt is equal to W by Q. Okay. Yes, see, this one is tricky here, and we have this form E now. E. So W by Q is equal to Vt is equal to I into R plus R. Yes. So the terminal or the total or the practicable applicable voltage is equal to I into V is equal to I into R plus R, the small and the big resistance. So we can call it another equation. We can stop worrying for now and get to the next issue, which is power in terms of electromotive force. Power with respect to electromotive force. Power with respect to electromotive force. Okay, so power is work by time, and work done in electric circuit is W is equal to QV. So P is equal to QV by T. Yes, and I is equal to Q by T. Charge by time is current, so P becomes IV. Yes, so this is the form we have, and V is equal to IR, as we know. So P becomes IR, or P is equal to I square R. Yes, and we know that I is equal to, from previous establishment, E by R plus R. Yes, so we have 1 here, we have 2 here, we have now a substitution to make. Or just assume the relative equations and their substitution. So P is equal to epsilon by R plus R whole square dot R. Yes, this is the form. When we open it, P is equal to E square by R square plus R square plus 2R R dot R. Yes, this becomes the situation. To make it R minus R whole square, we do mathematical manipulation. R square plus R square plus 2R R minus uh, uh, plus 2r minus 2r. Yes. Okay, so what happens is we get epsilon square dot r by now r minus r whole square plus 4r. Yes, so this is the form we get. And this is a very workable form, but for further approximations, let's say in a circuit where capital R is approximately equal to small r, so in this situation power would be epsilon square r by r minus r whole square plus 4r, which means what? Which means epsilon square r by 4r, and r cancels out, v is equal to epsilon square by 4r. So this is a very simplified version where the small and the big resistance are somewhat the same.